A pleasant day to everyone. My name is Chris Almor Villarte and this is my report about weighted graphs. Weighted graphs. A weighted graph is a graph in which edge is associated with value called weight. The value can represent any quantity we desire. The value can represent any quantity, could distance, time, or traveling. So this is the example of weighted graphs. So as you can see on the example peak, there is an edge and every edge has a corresponding weight. So that is the definition of weighted graphs. So now let's proceed to Hamiltonian circuits. So what is Hamiltonian circuit? Hamiltonian circuits is a path in a graph that uses each vertex exactly once and returns to the starting vertex. Is a path that begins and ends at the same vertex and passes through each vertex of a graph exactly once. In short, kung saan nagsimula ay doon din magtatapos. So these are the examples of Hamiltonian circuit. Example number 1 is we begin to A, to vertex of B, vertex of C, vertex of D, vertex of E, and vertex of F, and comes back to A. And so as you can see, we started at the vertex of A and ends in the vertex of A and pass through each vertex exactly once. So here are the another example of Hamiltonian circuit. So we have vertex A, to vertex B, to vertex C, to vertex F, to vertex E, to vertex D, and comes back to vertex A and pass through each vertex exactly once.
Now, let's take this example for you to understand how the weighted graphs work. So, suppose a traveler would like to start in Chicago, visit the other 5 cities this airline flies to, and return to Chicago. Find 3 different routes that the traveler could follow and find the total distance flown for each route. So, based on the problem, we will start in Chicago and then pass through the other 5 cities which this airline flies to and then return to Chicago. So this is an example of a Hamiltonian circuit because we will start in the same road, which is Chicago, or the same location in Chicago, and then we will return to the same location, which is again Chicago, and we have to pass the 5 cities. So we have to pass through the 5 cities. So this the route which we need is a Hamiltonian circuit. So this is the table with presenting the 5 cities with their corresponding number of miles. This is, by the way, in miles, guys. So the numbers in these rows and columns are in miles. Okay. So now this is our solution. So let's sketch a weighted graph first. So we will put 9 dots or 9 vertices to represent the 6 cities. So from Chicago to New York, we will connect that. So it weighs 713, so that is its weight. So 713 miles. So from Chicago to Washington DC, so that is 597. So try to look back at the table presented a while ago. So from Chicago to Philadelphia, that is 665. From Chicago to Atlanta, that is 585. Chicago to Dallas, 803. From New York to Atlanta, that is 748. From New York to Dallas, that is 1,374. From Washington DC to Atlanta, that is 544. And from Washington DC to Dallas, that is 1,185. So from Atlanta to Philadelphia, that is 670. And from Philadelphia to Dallas, that is 1,299. So this is our weighted graph. So you just need to follow the table being given in order for you to construct the weighted graph or sketch the weighted graph accurately. Now, we will try to find a route, specifically a Hamiltonian circuit, because that is being asked in the given problem. So let's try this route. So if we start from Chicago and then we go to New York, to Dallas, and then to Philadelphia, and then to Atlanta, and then to Washington, D.C., and then we go back to Chicago. So this is a Hamiltonian circuit. So try to watch the video of the Hamiltonian circuit first in order for you what Hamiltonian circuits are, and in order for you to understand this concept or this situation. So this is our first route. Now, let's find the total number of miles traveled by simply adding the corresponding weights in each edge. So we have here in Chicago to New York, so we have here 713, so this one. From New York to Dallas, that is 1,374, so this one. From Dallas to Philadelphia, that is 1,299, so this one. From Philadelphia to Atlanta, that is 670, so this one. From Atlanta to Washington, D.C., that is 544. Okay, this one, so 544. From Washington, D.C. to Chicago, so that is 597, so this one. So we will just add them, the weights of the corresponding edges, to get the total number of miles traveled. So we get 5,197. So this means that we will be traveling 5,197 if we will follow the first route. Now let's take our second route. So we could have this one. So if we start in Chicago, and then we go to Philadelphia, and then we go to Dallas, and then to Washington, D.C., and then to Atlanta, and then to New York, and then to Chicago. So this is our second route, and the same thing we did in the first route. So we will add the corresponding weights in every edge. So in order for us to get the total number of miles traveled. So in Chicago to Philadelphia, that is 665. So this one, Chicago to Philadelphia. So from Philadelphia to Dallas, that is 1,299. So from Dallas to Washington, D.C., that is 1,185. From Washington, D.C. to Atlanta, that is 544. From Atlanta to New York, that is 748. And then we go back to Chicago. From New York to Chicago, so that is 713. So we will still add them so that we will be able to get the total number of miles traveled. So we get 5,154. So this is the total number of miles traveled if we will follow our second route. Now for our third route, since we need to determine third routes in this graph, so we could have this one. So from Chicago, we will go to Washington, D.C., and then to Dallas, and then to New York, and then to Atlanta, and then to Philadelphia, and then to Chicago. So similar procedures. So we will be adding the corresponding weights in each edge to get the total number of miles being traveled, and that is 5,239. So remember that in Hamilton, so take note that we are considering a Hamiltonian route in this graph because that is what is being asked in the given problem. So we are asked to start in Chicago and then to return to the same destination, which is still Chicago, and we still have to pass through all these cities. So we need to start in Chicago and pass through all these cities. So that is why we are considering a Hamiltonian circuit.
So now let's proceed to Dirac's theorem. So what is Dirac's theorem? Dirac's theorem is proposed by Gabriel A. Dirac. So Gabriel A. Dirac earned his doctorate from the University of London in 1952 and has published many papers in graph theory. He is the stepson of the famous physicist Paul Dirac, who shared the Nobel Prize in Physics with Erwin Schrödinger for his work in quantum mechanics. Dirac's theorem. So what is Dirac's theorem? It states that in a connected graph with at least 3 vertices and with no multiple edges, if n is the number of vertices in the graph and every vertex has a degree of at least n over 2, then the graph must be Hamiltonian.
Let's take this example. This graph represents the available flights of a small airline. So an edge between two vertices in the graph means that the airline has direct flights between the two corresponding cities. So for example, Portland to Reno, so we have an edge connecting the vertex of Portland and of Reno. So therefore, this edge represents the direct flights of these two cities. So we could say that Portland and Reno has direct flight. Now, the number of vertices in this graph is we have 6. So 1, 2, 3, 4, 5, and 6. So we have 6 vertices. And every vertex of the graph has a degree of at least n over 2 equals 3. So it has a degree of at least 3. So at least half of the number of vertices. So for example, in Portland, it has a degree of 3. So we have 1, 2, and 3. So in Butte, it has a degree of at least 3. So we have this 3. So 1, 2, 3. In Boise, it has a degree of 4. So 1, 2, 3, and 4. So if we count the degree of every vertex in this graph, so it is at least half of the number of vertices. So by the Dirac's theorem, we could say, or we could tell that the graph is Hamiltonian because we have met the conditions of the Dirac's theorem. So for us to tell that this graph is Hamiltonian. Now, since this graph is Hamiltonian, then we could find a Hamiltonian circuit in this graph. A Hamiltonian graph is a graph that contains a Hamiltonian circuit. So let's try to find one. So for example, we have here, if we start at vertex Portland, so if we start here and then we go to Boise, to Butte, to Salt Lake City, to Reno, to Sacramento, and then we went back to Portland. So this is a Hamiltonian circuit. So again, this graph is Hamiltonian because this graph has met the conditions of the Dirac's theorem, and this graph also contains a Hamiltonian circuit. So we could also have this one. So if we start here in Portland and then we go to Reno, to Boise, to Butte, to Salt Lake City, to Sacramento, and then Portland. So this graph is Hamiltonian. Now, one of the limitations of the Dirac's theorem is that if it is not the case that every vertex has degree of at least n over 2, then the graph may or may not be Hamiltonian. So, in other words, if the conditions of the Dirac's theorem are not met, so the graph could still be Hamiltonian or not. So, Dirac's theorem will not tell us if the graph is not Hamiltonian. So, it only helps us in determining if a particular graph is Hamiltonian, but it will not tell us if it is not.
So that's all on my part, and thank you for watching.